And welcome and good evening. Please raise your hands if you can hear me. I can hear myself. That's at least a good sign. And yeah, we are starting now. Hello Horst, nice to see you again. To the second part of Life Still Goes On. The pandemic is going on, but it's getting better, I think. And Game of Life, we stopped last time at a crucial point. As a quick reminder, we want to code Conway's Game of Life, which I will bring up here again. Conway's Game of Life, which is a cellular automaton. Very simple rules. And should be easy to implement, but we are making life hard and trying to do it in MS-DOS with assembler, so to make it a bit more interesting and educational. Last time we stopped at this stage where we were able to plot a pixel. Not sure if this one is correct though. Yeah, should be. It's probably the right one. And this is our code from last time. For those following along at home, I added the gist link to the last episode, and you have to glance over all the time to see your chat messages. Again, you have to shout really loudly if you want to get my attention. Yeah, anyway, you can have a look at the code, you can download it, you can play with it at home. And what did we do? Yeah, we initialized mode X by just porting the stuff that I did in the Let's Code C episode. Hi Lorenzo, welcome. I think you were there last time as well. I recognize your icon, your avatar. And we programmed the main loop where we wait for a keypress basically, and before that we are calling setPixel. But looking at this and looking at this here, indeed, we thought we had it going, but what's the actual stuff that I have here? But looking at this, I think we should have plotted the upper left pixel. And I'm still not convinced this is 100% correct, because this is not the upper left hand corner pixel. Maybe we should test this a bit more. So calling the function is a bit complicated because we have to push all the arguments onto the stack. This is also not the 15th pixel, right? Because we're pushing here 0f for the color. So in theory, if I change this to something like 1, this should be blue. So let's try this first to confirm that we have indeed. Oh no! This just changes the coordinate. Okay, then maybe something wrong with the order of the arguments. We had thoughts about that last time as well, I remember, right? We were thinking that maybe the arguments need to be ordered differently on the stack. So let's try the following. But then I'm wondering why I get anything at all, because I'm pushing a lot of zeros on there. We could debug it. We have the debugger, as we remember. I'm just gonna recycle one of the DOS boxes. Which one was it? I think ball and C, right? We used the one that is in ball and C. Something like TD, yeah, exactly. So let's load the file. It's a COM file in the turbo assembler directory, and it's live.com. Program has a symbol table. I'm fine with that. Then we are looking down where all the pushes happen here. Here the pushes happen, and then we will have the call. So that was, I think, F4, and then F7 to step into. All right. Now, looking at the set pixel routine, do we actually use the color? Let's see. The set pixel procedure takes the VGA page, the X, Y, and C coordinate, the X and Y and the C color. And compute VGA offset. Here, there's VGA page, and X and Y are loaded here. So the color comes last. We are not using it. Oh, okay, that was the problem. Yeah, okay. So let's use the color. This will change everything quite a bit. No, I'm not going to debug this right now. Nobody's shouting. Okay. Okay, no, I'm not seeing squat, which means that I'm probably plotting a black pixel, which means I'm just gonna do it. I'm just gonna take this and put this in front of everything, because I think it's the wrong way around. Stupid me. Still not seeing anything. Ah, crap. Okay, we need to debug. So open com file. No, yeah. Can I reload? No, I can't. But I'm gonna change the directory so we don't have to swap around so often. Yeah, live.com is here. Write a bat file. Yeah, let's write a bat file. Why not? Let's write a bat file called, I don't know, but we'll just do tasm live.asm tlink /t-live.obj, and I'm not going to do anything more. And I'm going to write this to tasm. I'm going to call it mk for make. Oh, .c. That's not cool. Tasm mk.bat. This way we can just do not running because I want to see the error. Otherwise, we need to check error codes and stuff, and that's just fine. We can do it like this and run it and quit it. But let's not get sidetracked with the tools. Feel free to write some tools, and you can submit them to me, that we get a better environment here. Okay, this was loaded. Again, there's the push, there's the call, F4, F7 to step into this. And first things that we are doing in the set pixel procedure is setting up the stack frame and then loading X. So CX is now 0. X is 0, which is fine. Then going here, we are loading AX with Y, I think. Yes, this is this part that we are currently seeing. Mov AX BP plus 8 is loading the Y coordinate into AX, which is also 0. That's fine. And then loading X again, which is also fine. And after that, we are loading the VGA page, which is wrong. BP plus 04, or is it? Call pushes the return address to the stack 2, if I remember correctly. Yes, it does. That's the very first thing on the stack. As far as I know, that's why we have the call routine, otherwise it would be just a jump. Because everyone knows bash C shell, but no one knows how, if it works. Yeah, Windows bash is actually, I think, pretty powerful. And there's also Windows PowerShell, of course, which I never learned. I just went the Linux way with bash and Z shell and stuff. Okay, let's do the thing that we tried last time by writing some special stuff into the register so that we know what we are dealing with here. Let's not push zeros, but let's rather I'm gonna first again write 1, 2, 3. I'm gonna kill this so that we exactly know which is which. We did this last time and I thought we established a rule how this goes here. 5, 6, 7, 7, 8, 9. Memory inspection tool, yeah, of course, but we already see more or less what it looks like, don't we? Sorry, open. So call F4, F7, and there we are. That CX is now 5, 6, 7. So this is actually the X coordinate. So this is the third one on this tag. That means this is the last one. This should be the color. This must be the color. This is the Y coordinate, I would say, and this should be the page. Let's see if this is true. AX is loaded with 4, 5, 6. That should be Y, yes. And then we are gonna load X one more time, and then we should add BP plus 4. So let's see if we can actually, as is at the bottom right, probably shows the stack contents. Yes. Can we view this? View stack. That's pretty useless. Close. View. Can we just dump? Open the dump window. What's a dump window? Nice. Yeah, the thing is, that would mean that we need to go all the way to the bottom. If we want to look in there, I think, because the stack should be at the end of the segment, right? And here it was. Here it was. No. Okay, so, but the question is, okay, we would have to convert this to, we probably should have used hex values, shouldn't we? We probably should have used hex values, because I didn't I? That wasn't the, oh, I used hex values, so okay, where's 1, 2, 3, 4, 5, 6, 7. So this is 4, 5, 6. Oh, I used 5, 6, 7. Okay, then this is 5, 6, 7, 7, 8, 9. Okay, so the stack grows from the top. So this is the first value: 1, 2, 3, 4, 5, 6, 5, 6, 7, 7, 8, 9. All right. Stack has its own segment. not in com files, Thomas. I think we established that last time. In com files, ds equals ss and cs. I mean, you could probably modify it and allocate more memory and mess with the stack segment and stuff, but in theory the com file should be very simple, and cs equals ds and equals ss basically. Okay, but this doesn't really help us, except that we see that we pushed in the right direction basically onto the stack, I would say. But the important part is that we established that the first thing that they pick from the stack is the 567, and this needs to be the X, and we ordered them in this order: page X, Y, and Z. So I would assume if I change this to a 0, whoops, this to a 0, and this to a 0, and this to something like, let's start simple again, 0f, we should see a pixel in the upper right corner, hopefully. Yes, that works. Now I'm gonna do the next best thing and change this to, let's say 2. That should be red, I think, which should be reasonably visible. Now it's cyan, but it's still okay. And now I'm gonna move this halfway down the screen, 100 lines, to check if this works. Basically manually unit testing, and this worked as well. We are halfway down the line, the screen, and oh, this is probably hex. No, this isn't, because that would be 255. But let's also try just incrementing x by 1 to see if our mode x calculation actually works, and that seems to be the case as well. You can see that the pixel here is now 1 pixel to the right. It's probably hard to see for you, but you can trust me. Okay, I would say the set pixel routine works, but the thing is we need to push them in this order: C, Y, X, and then page. Okay, I would say we could start, write a cursor key. Not right now. I would say we can really start with the game logic. We should be able to code the rules of the game, and for that we probably should somehow initialize the first couple of pixels. There are very, very efficient starting states with only like 7. Or yeah, we can try something simple like an oscillator or something, or a spaceship, just to see if the rules are working. Right, so the most simple thing is probably to have either a block or a blinker. The blinker is probably the simplest, because we just need to set 3 pixels in a row. And then we can go to doing random stuff or something like that. It works for 1 doesn't mean it works for 5. Yeah, okay, but we will see that. We will do that now. I'm gonna postulate that we're doing the following. You guys can already think about how to efficiently code a starting position so that it's very easy to pump into the memory. I'm just gonna try to put 3 consecutive pixels on the screen just for testing, and I am going to try one more thing, if we can see the blue color, because otherwise we need to change the color palette. It's very hard to see. Or we can simply, yeah, it doesn't matter which color we use. Yeah, using random state gives nice results, I guess. Yeah, we'll try that. But this will be a bit of work to initialize with random stuff, I guess. But for now, I'm gonna use white for visibility. Yeah, we can use the game state will live in VGA memory. Yeah, that's why I'm using mode Y actually, because we don't need to allocate anything or free anything, and we can just use 2 pages of the VGA as the front and back buffer for the state, because we need to look at the previous state and then update accordingly. So let's put this what's 100 in hex, halfway down. Decimal 100 is 64, of course. What else? 64 hex. Putting it halfway down, and then we are using, I don't know, somewhere almost halfway there. I'm gonna do this in an ugly fashion because I just want to have 3 pixels to test the game routines later on. 101. And we can optimize this later. So this should give us 3 pixels way over here. Okay, so these should be starting to flip when we code the game logic. Lorenzo says we could use the memory itself as a state by setting a tweak mode with all map mask planes enabled and the right number of scan lines. Probably. Which reminds me, we also need some get pixel routine, right? If we want to read out because the first approach will be slow, because we will swap the map mask register all the time. But I would say we should also write a get pixel procedure. And here the fun begins, because we need to be able to return something, and that will probably work. We can pass it in a register. I think that's simple. We can probably clone the setPixel routine. What did I do? Nothing, I hope. So we're gonna write the getPixel procedure. We don't need any 4th argument, but we still take the word and the other thing. We select the right VGA plane, is the same. We compute the whole offset, which is fine. But then we are gonna load AL with this thing here. And the question is, does this work, or do I need to use the source index? We will see. But I think this should be the only difference, because we're setting up the DSDI pointers again, and this has to go, and then loading whatever is in VGA memory at that position. That should work. Wouldn't vanilla mode 13H be easier? I know, where's the fun in that, but still. The thing with vanilla mode 13 is we don't have a front and back buffer, and as I said, we need the previous state, the previous iteration for Game of Life. So we need 2 buffers. We can use just some segment. We can allocate, get a pointer, far pointer to some segment. But I think it's cooler to actually have that we don't have to copy. I know that accessing VGA memory is slow and stuff, but I think this is probably good exercise to try this out. You're free to do your own implementations. Oh, unmatched NP setPixel. Yes, getPixel it should be. And it compiles. It doesn't do anything because we don't call it. We could use RAM as a back buffer, but then we have to allocate a segment, because with a com file we don't have any of that. And I think it's it's cooler to use the VGA memory. It's just, I just like it. Yeah, the way we're using mode Y, it definitely will not be faster because we are switching the map mask all the time. That's the later optimization that we do this whole stuff here, selecting the VGA plane only when needed, so that we first compute the first plane, then second, and third, and the fourth. We can allocate. Of course, we can do everything we want. It's just a DOS program. But I don't want to. I want to code it so that it runs more or less directly on the VGA card. As I said, feel free to fork the gist and do a different implementation, and we can have a look at that at some later point. Mode X and Y are slow if you do it like this, like we're doing now, but we will optimize it. And VGA memory itself is of course slow because it's going over the ISA bus. And it's definitely not the most optimal solution that we're doing here, but I always wanted to try to do it this way because it's a nice programming task to do that in mode Y. Yeah. So, anywho, we can now read a pixel, we can set a pixel, and we should make a procedure called update game or something, I would say, which does the game updating. And it should get the VGA page that it's using because it has to pass it, and then we can just toggle the page all the time in the main loop. So basically in the main loop we would do something like this: push VGA page, and we need to define that variable, and then do call update game. Let's call it VGA page 1 or something. And then we could swap VGA page 1 for VGA page 2. Mode Q, yeah, mode Q is, what was it, like 256 by 256, right? Never used it so far. We can probably do something with that later. And how do we swap? We probably have two variables, I guess. Of x VGA page 1, of VGA page 1. Can we actually do two memory? No, we can't, I guess, right? We're doing move vx VGA page 2 of x VGA page 2 and mov x VGA page 1. Or is there a swap command? I don't know. Yeah, we the complex XY to address logic, yeah, we can eliminate that. As I said, we could switch to that later. We can define constants for all that stuff and rewrite it for 256 by 256. But first, it will be hard enough to get the game loop running, so let's first concentrate on that. Then I would need to define that variable, I guess. Where did I put the, do I have any variables here? No, not right now, right? Okay, there's iTunes annoying me. I'm gonna quit it. I'm gonna quit it. Yeah, stupid thing. There's some XOR swap trick. Yeah, the XOR works, but I'm not sure if it works on yeah, actually that's true. That's actually true. We could use the XOR, but I think that doesn't matter because that's just really destroys the readability. Something that we can do later, I would say. So I would say we need to define a variable. And that worked. How exactly? We had the hello world. So variable name, db, and something. I think if it's a byte load, but we need a word. Not seeing my chat window. Okay, here. VJ page 1, db, yeah, the word. So that should actually, this should be easy. This should just be 64,000 for the second page. Is that right? No, that's not right. That's actually 16,000 because we have to divide by 4 for mode X or mode Y, and that should be 0. Yeah, that's correct. So in mode X and Y we need to divide the size of the screen pixels by 4 because we have the 4-bit planes that we have to select. So we only see a fourth of the memory at a time. So at byte 16,000 decimal, the second page actually starts. So will this actually compile? It does. I'm surprised. But it's not doing anything yet, but it should at least not crash. Oh, it gives us, interesting. It gives us a few random pixels. And it doesn't quit. I crashed DOSBox, which is nice. Let's open another one. Why do we crash DOSBox? Why did we crash DOSBox? Because we never return, right? Because we never return. Push BP, MOV, BP, SP, and red. This should be better. Also crashes. Okay, we're still doing some garbage here. I need to redo my layout here so I can quickly restart. Okay, what are we doing? So we are crashing. We are calling update game, then swapping our page in theory, and then doing the main loop. But it doesn't work. Why does it not work? Which TOSM version do you use? Horst asks. That's TOSM version 2.0 or something. Yeah, TurboAssembler version 2.0. The reason being because I was using TurboC 2. something for the other Let's Code videos, and for nostalgic reasons I'm sticking with that. And it's actually powerful enough for everything that we're doing right now. In theory, we could just use MS-DOS debug to enter everything, but that would be even more painful. So yeah, not going to do this today like that. I think it's time for the debugger, right? Because we are crashing. It's probably good to look what's happening here. So we can go down to the main loop. So we are calling 0180, and then we are calling, let's go here, F4. Oh no. I accidentally pressed run. That wasn't the most clever thing I did today. You can all laugh at me. but don't be afraid. We will get it to work. For sure. Actually, that's wrong. I need to go to... I can just run it from here. Ball bin td. No? Ball and C. That's right. Open all the conf files, please. And then we go until here. And then we are... Where did it go? Oh, it already jumped into this thing. No. Okay. Sorry, I went into the setpix routine once more. And here's the return. And now we're pushing the word pointer. And then we're calling the other routine. And this just does push pp, mov pp, sp, return. Then it jumps back. I think there's the corruption, because that was not where we went. Program reset. Did you see that? I think there was a mistake. So let's just go to the address 180, because that's our... No, not 180, there was... Which was the function? This one here. 17a hex. Divide by 0. Oops. Ah, interesting. It never got there. Program reset. Okay, I think there's some corruption going on there. Let's take a look at the definition of the update game routine. No, we are accepting a word here. No ideas in the chat. Well, that's too bad. Interesting. What is the deal? I'm still online because I think my browser is hanging. Okay, no, I think I'm still good. Okay, just check the streaming status. But nobody's complaining, so either nobody's watching or you guys think everything is all right. So, we're basically doing the same thing as down below here. Oh, we need to pop the base pointer. That is, of course, bad. That's bad luck, not popping the base pointer. That usually leads to a crash. And DOSBox also has a debugger. Well, that's lame, because actually, in theory, I could fire up the 386 and we just code on that, but rebooting will be slow. Okay, still hanging. I'm just too optimistic. We have all the crashes here. Yeah, but that's cheating, I think. Using the DOSBox debugger is cheating. I'd rather like to do it with the original tools, because in theory you could just fire up a DOS PC, maybe with Windows, to run different programs at once, like having Turbo Debugger and an editor and a shell open at the same time. That wouldn't be cheating, that would be sort of like period correct work, so to speak. So let's go to the place where we call the actual function. Let's go here. And if I jump into this, we do the push BP, that's fine. We do the mov pp sp, we do the pop BP, and then we do the red. And then I'm returning here, which is fine. I'm swapping the variables, at least I think I did. Although bx looks suspiciously 0, then we are asking for the keyboard and continuing. Then we are going that route again, and all goes in a loop. So in theory, this should work, but it doesn't. Period correct pain, yeah, of course. That's half the fun of it. Otherwise I would just be coding Python or Go or maybe even Java or something, but no. I have to earn my money with painful C++ code, and in my spare time I do x86 assembly. Because that's slightly less worse than C++. Okay, it doesn't have history that far. It doesn't store the history. Okay, so so in theory it works, but for some reason we don't get the key press, because it looks like it's running in a loop, and I'm not sure why. Oh, why the hate for C++? No, I'm just complaining. I think C++ is limited because of its age. It's just a very old language at this point, and it just adds features without dropping any. And so the more modern languages are much more clean, much more easier to learn. But for what it's worth, and for its when it was designed, it's actually pretty solid. But there are many drawbacks, like non-standardized make systems, build systems, tooling, etc., etc. You can't even link output from different compilers. That's like a big oversight. I mean, they did that because they are very low level and stuff, but all the languages that run in virtual machines have a big advantage that you basically can take output from any language that runs on that machine and link it to another language. Yeah. So there are, of course, solutions. There are cross-platform build tools for C++, and there are some things for dependency management. But if you compare the state of affairs in C++ land and the one in Java or even JavaScript, which is like, there's a whole different hell there. But yeah, C++ has pretty big deficiencies in there. Plus the compile times are awful, so it's awfully slow for huge projects, and you have to buy third-party stuff to accelerate building, etc., or use some other tools, maybe open source tools. So those are my points of criticism for C++. But yeah, for example, I think the whole object-oriented programming is sometimes not well suited for some tasks, and people just use it because they can, and it makes things overly complicated, or so that stuff sticks together and you can't separate it anymore. Anyhow, still further digressing, I'm not sure why the keyboard doesn't let me quit. Maybe just for one quick test, I'm gonna disable the main loop and just exit, just to see if we are crashing before that, because I think we are running. We're still running, but we don't get the key press. Okay, that's fine. Are we querying this too fast, maybe? I could think that maybe we are giving DOSBox not enough time to actually process the keys or something. Question is, how do we get it to actually work correctly? Let's also check the interrupt 16 function. Get keystroke status. Okay, they just look at AH and we set that to 1. And everything else is fine. Hmm. $10,000 cycles, yeah, but that would be stupid if I have to change the DOSBox cycles. But anyway, I think we should, where are my gists? We should take a look at, is it in here? No, this was that one. I think in the smooth scrolling I have the wait for the vertical retrace, because we could sync with the vertical retrace actually. We could do this stuff here because we don't want the game of life simulation to run too fast, so at maximum we take the 70 Hertz or whatever we have on the VGA card, right? So I would suggest we wait for the vertical retrace. Maybe that gives DOSBox also the time to process the keys, maybe? I don't know. Plus, what we also didn't do is we didn't clear the VGA memory. Maybe those are the colored pixels that we're seeing. You could break out of the main loop after maximum number of iterations to not depend on a working keyboard. Yeah, we can. I already thought about that as well. We could do it like this. Let's do this actually. So CX and no, let's actually morph CX comma, I don't know, 1000, something like that. And we are doing like this. We are either breaking with the so we are doing dec CX, which decreases CX by 1. 2 bits in, your text is visible. Read port 0660 instead of BIOS. Yeah, we can also do that. We will figure that out. But I also want to have like a safeguard to quit after like 1,000 iterations, which should be rather quick. Well, let's do 100 to be sure. Decrease CX, jump if 0 to exit. Pressing random keys now. It's probably working better than anything else. That was quick. Let's increase that to 1000. What? Okay, I didn't. I just toggled the insert key. It's still very fast. Oh, wait a second. That probably doesn't work. Yeah, I think CX is probably getting overwritten by maybe even by this one here. No, it doesn't. But it's probably a bad idea anyway. Let's introduce another variable. Let's introduce insert, so that's better. Frames. Let's say we do 1000 frames. So we are, what are we doing? We probably can't decrease a memory location, right? That's probably not possible. Let's take a look at the assembly programming topics. Decrease and decrease. Operands are register, Oh, mem actually works. We can give it a memory location. Okay. DAG frames. And then we jump to 0 if jump to exit if it's 0. Ah. That takes suspiciously long. I think that doesn't work. I think that doesn't work. That should be... Okay, we need to debug that. I think there might be a part 3 if we progress like this. Let's see. Look at that. Here we are. So, can we watch this location, this memory location? Probably, right? So, can we put a watch on this? Data, add watch. Can we watch 0209 or something? We can. But that's sort of 0, which is not that good. Okay. Oh, okay. So, yeah, if we wait for vsync, but we don't right now, but we should. That's true. And if anyone's wondering why it says here JE while we wrote JZ, it's actually the same. Testing for the 0 flag or for equality is actually the same, because equality is tested with a 0 flag in the flags register. So this will not happen. And on the next run here, let's try to come around here. We are just counting down, and this takes a long time, obviously, right? Because for some reason the value is wrong that we have here. And I wonder why. Because I wrote here frames equals 1000. Any ideas why that is the case? Why it's 0? I think that doesn't make sense. I think that's not what it should be. Learning assembler is hard, obviously. Interesting. I'm not quite sure. More frames 1000 before the main loop as a heck. we are basically, yeah, we can try that. Move frames 1000. Oh, we have to kill it. Kill it again. Kill all the DOS boxes. There should be a button reset DOS box or something like that. Nope. This time I'm gonna check right away what's happening there. So let's go down, find the place where we are here. So before that there should be jump equal 17e and 15e is the start of the loop. So okay, this is where the morph happens. Ah, look at that. Yeah, no, that's fine. So both memory locations are 020C, and in theory we should be able to add a watch onto 020C. Come on, can I clear this? Let's do it like this. Okay, it's currently 1000. okay. I'm confused. So let's go there. Let's call let's see what happened here. Why is it 020C again? That's not good. When did that change? So I'm gonna reset because I don't trust this. Reset, and we run until here. Then we no, this can't be. So once more, reset. You all see that it says 1000, which is fine. Then I'm letting it run until here, and suddenly it's 60, so it's 4 Fs. That's weird. And then I'm gonna write did DS change? Yes, DS changed. Because we loaded DS. We didn't restore DS. DS points to the VGA memory. That's also why we see the pixels, I think. The colored pixels. CRUD. That's because we wrote to the VGA memory and we didn't restore DS. So let's go to the setPixel routine. We need to store all the nice things. So what are we modifying that should not be modified? We definitely need to push DS. And that's probably the most important thing. The rest of the registers I think I don't care about. So I'm gonna pop DS. Same goes for the get pixel routine. Push DS. Did I do that in the right order? Yes, after moving the stack pointer, I did the push. Push DS before push BP? I think it doesn't matter, does it? Use ES, yeah. We can also... I mean, we're messing up the segment registers, and I don't like that. We should definitely store whatever segment register we use, I think. Use ES. I think for the arguments, it's important where the base pointer is. And I think if I push DS after MOV BP SP, that's fine. Then we are pushing inside our local stack frame, and they are referencing relative to the current stack pointer, and that's important. If we push before that, then stack pointer is again messed up. So I think this is the right way to do it. Here we did the push DS, and then we need to pop DS as well to stay in sync. Stores B, what? Yeah, that's actually nice, yeah. Morph DS, CS. that actually doesn't work that way, I think. Maybe? But anyway, yeah. I'm not going to do that hack. But I know it was with a smiley. Let's open the DOS box. Here you go. Now it doesn't hang anymore. And if I had to guess, I would say that it will even work without our frame counter. Let's comment out the frame counter, because I think that messed up quite a lot of stuff. Where's our frame counter? Here. So I'm gonna, first of all, I'm gonna kill this here because that's not necessary. I'm gonna do that as well. And I'm gonna swear it will work. Famous last words. Okay. Anyway, did anyone have a successful day? I sure as hell didn't. Not like this. Oh no. Oh no. Oh no, you don't. Are we still visible? Something is wrong with my stream, I think. What? Crud. Sorry, having technical difficulties with my setup. Stream is still good, yeah. In 16H is non-blocking, at least function 1. We looked it up. Function 0 is blocking, function 1 is non-blocking. Yeah. I just messed up my OBS setup, but if you're seeing everything, then it's good. I just renamed my scene and I was typing in the wrong window. My scene is now called CD, which is fine and it won't rename, but we have to remember CD is where you see my desktop and see me as well. That's fine. Okay, so that's good. We are gonna go with the frames and we are gonna do the horizontal sync anyway, I think, because otherwise we don't see anything. Because then we just see a flash like this, those with 1000 frames, and I think that's too fast. Yeah. So I would say we hard code the vsync here in the main loop. You don't do a procedure for that. Do vsync. I'm gonna write this here. Update game state. Maybe that will help with the quitting as well. Let's see. So how to do this? We should be able to do this just like here. We need the input status register, and the input status, I'm just gonna take this from here, 3DA. For readability, we will define this down here. Input status equals 03DA hex. And where's my main loop? Here's my main loop. And we need to do it like this. Creative names, loop 1 and loop 2. Then we're going to do in, oh, now comes the fun part, right? We had this, there were limitations on how you can use in and out. We have to use dx and ax or something like that. So we will do in, where does it read into actually? In accumulator, comma dx or immediate. So dx will take, okay, let's see, maybe I should read. A byte word and placed into a, okay, it reads into the accumulator and we need to use dx for the port. Okay, that's fine. So it will look like this. Mov dx, comma input status in ax, comma dx, By the way, mov x VGA page 2 and then mov x VGA page 1 main loop looks wrong, redundant. Yes. Yes, but that shouldn't crash anything. That's just stupid. So this should be better. This should do the swap. Probably not the most performant swap, but we can always change that. So, I hear birds. Do you hear birds? I can hear birds. What did I want to do? Yeah, okay. So we have to check the vertical retrace bit, and that was 8. Okay, so basically AND AX, 08H, right? Because that's what we read. I probably shouldn't have used AX, I should have used AL, because we read only one. In ALDX and AL comma something, and then what does it say? While it's 1, so or not 0, so jump not 0 loop 1. Is that right? Should be. And then we're doing the same again. And careful not to use loop 1 down there, or we are stuck in a loop, in an infinite loop. And this should be jump while 0. So while not input status NV retrace, we are fine. So, do you guys think this is correct? Are we now in sync with that thing? And I'm gonna reduce the number of frames, because with 70 frames per second, this will already be more than 1 second, and we'll notice it if it quits. If we are waiting for 15 seconds, that's always very slow. For now, I just want to be on the safe side. Boppity boppity boo. I think this should be fine. I'm just gonna try it. We don't need to wait. Make. There's at least no error. And it quits. Well, that was a surprise. That's a welcome surprise. Let's crank it up to 1000 and see if the keyboard works. Okay, I'm still toggling insert instead of doing useful things. Look at that! Ha! 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 Take that, DOSBox. So basically, I'm not sure if it's a limitation of the emulation or if it's a general problem with the PC, but I would almost guess that it's maybe a limitation of the emulation, because the main loop was probably way too tight that we never could quit. Maybe that was a problem, but what we actually achieved now is we have vertical sync. That means we are waiting for the vertical retrace on the CRT, and we get at most 70 Hertz, so 70 frames per second in our game loop or main loop. Yeah, and that's very useful, and that gave the emulator, I think, enough time to actually do the key code processing, and yeah, it works. Okay, so we have set pixel, we have get pixel, we have the whole loop thing. We can now, and we have set 3 pixels. In theory, we can now first of all swap pages and do the actual game code, because that's still missing. But once we have the game code, we are actually almost done, because then we just need to initialize a nice beginning state actually. So yeah, we won't want to do that too quickly, would we now? But I would say we should swap frames as well to see if that works also, actually, we already do for the get pixel and set pixel routines and the update game state, but we don't do it. We don't tell the VGA. We have to tell the VGA, and yeah. That's not that hard. We have everything here on screen, I think, because that's this here. That's the start register high and low. 2 bytes. That's no problem. That's 2 out calls and a bunch of ands and shift right. The VGA page 1.2 swap code needs to swap variable and register. What, Thomas? Yes. Yes, you are absolutely right. You're completely right, of course. Thank you for noticing. Otherwise, we were doing nothing. Nothing at all. Code that does nothing is always the best because it doesn't have any errors, I would say. Stream is still fine here. Thank you, Thomas. I think you are lagging behind. Did you pause? Maybe. I'm gonna write this to you because otherwise it's did you pause the stream? That was like 10 minutes ago. Okay, nobody tell Thomas what's happening after that. He's probably in for a surprise. Yeah, that's a problem with streams. I can already see you're lagging like half a minute behind, like THP and Horst and the others. Because I'm saying something and then half a minute later I get your reaction. But I'm not going to turn down the delay because last time we had massive streaming problems. 20 seconds, yeah, that could be 20 seconds. Sounds reasonable. I can turn it down, but I'm not gonna try. I'm set to low latency. There's extremely low latency, but last time that didn't work out. So I think we're good, and the chat is immediate, so I can react to that immediately. Okay, we fixed that. We need to do the actual swapping of the, oh god. Here, we need to do this stuff. I'm gonna scroll this a bit down so we see that. And start register high and low. There we are. Let's put that down here. Start register high equals 0 ch, and then crud, I did something bad, I think. What did I do? I think I don't have any undo. Is there an undo in the editor? Did I do anything? I think I just scrolled down. I think I scrolled down because I wanted to copy. Low is DH, CRTC index and data. We don't have that yet, so I'm gonna copy the sequencer controller variables or constants CRTC index and CRTC data, and they are D4 and D5, so that's good. Update game state. Yeah, we're doing this here. Set VJ page. Yeah, I wanted to go down here and here. Mof dx comma start no CRTC index, CRTC index, and we can, shall we do the trick where we do the out dx comma ax thing? I think we can do this. This will do 2 writes in one go, because here I'm doing 2 writes. I write 2 bytes, and we can do 1 word in one go, which will automatically increment the CRTC index port to CRTC data. That's one nice thing that they used. So for people who don't know that, if I do out dx with a word value here, then it will write 2 byte values, but it will first use dx as the port and then dx plus 1, which is exactly what we want, because CRTC index is 3d4 and CRTC data is 3d5. So we save 1 instruction, basically. We don't have to write that. But we have to set up AX correspondingly, and I have to remember if it's AH or AL that gets written first, and we probably should have a look at the reference here. But they don't say, right? Does anybody know from memory x86 assembler out word? Maybe one of those links. That's actually not quite true. Yeah, exactly. You're right. I would say AL is probably the first byte, because that's what makes sense, and that's what I would assume. So let's go here. So I would say MOV AL comma start register high, and MOV AH something VGA page 1. Did I call it this, or was it with an underscore? No, I just took one word. VGA page 1, and then and AH comma. Oh no, that's crud. I'm stupid. That's garbage. That's garbage. I can do it much easier, right? Because I can just I have to move this down. Let's say I'm doing this, and I'm gonna move this down here. So AX contains now VGA page 1. I'm not sure why I did the FF00 here, because that's absolutely not needed, because I can just do shift right or shrew AX comma 8, but that doesn't work because we need to use CL or some weird thing, right? Because that was the problem last time. So let's look at shift right. Shift right takes CL, yeah. CL, MOV CL comma 8. Then shift right AX by CL, and then then we need to do MOV AH comma AL, because we now moved all the higher 8 bits to AL. We need to move them back to AH. Actually, this is totally we don't need that. We just move that there and overwrite AL and be done with it, because then we just delete the lower 8 bits. Are you agreeing with me? Of course you are, because you are 20 seconds lagging behind, so you can't say anything. Anyway, so this is the this is the higher register, and then we need to do the following. This is now much more interesting. We can actually morph cl, 8 and then do shift left ax, cl, which will move the 8 bits from AL to AH, and then we can load with AL with start register low. And I think that should, of course, also be fine. Of course, out should support to output a word after all its 16-bit architecture on everything except PCXT. Yes, in theory, Horst, you are right, but that's the way the PCs work. They are weird little creatures. And at least until a very short time ago, even the most modern CPUs still booted up in real mode, being only able to access 1 megabyte of RAM. And that's after more than 30 years of this architecture. But I think the most modern i9s and stuff like that don't have that anymore. Thank goodness. So, is everybody agreeing with me? Here we just want to write the high byte, and that's done by just loading the VGA page word and overwriting AL with a register. Yeah. That might well be that the UEFI BIOS replacement starts in Unreal mode. Could be. I'm not sure. I mean, it's much harder to figure out this stuff nowadays. But there are probably resources for that as well, I guess, because I think the Linux developers have to know. So maybe I should figure that out at some point and write my own bootloader for the Mac or something. If I'm allowed to, if Apple allows that. But I think my Mac is so old, it doesn't have any T2 chip or any crap like that. So I'm gonna try and test this out. No errors. At least we're getting better with the syntax errors. Oh, and I see flickering. That's awesome. It's flickering. That means it's actually swapping. That's so awesome. We are almost there, and it's only 10 o'clock. So we might see something by the end of the stream. That would be so cool. We have vsync, we have page swapping. Now doing the main the update game stuff. And this will be a bit harder. One thing that we need to keep in mind is that we don't read or write pixels that are not on the screen. Due to that, I would suggest we start our loop at not at line 0 and pixel 0, but line 1 and column 1, and stop one column and row short of the end of the screen. We could also do like a wraparound. We could use a rhetorical word. That means if I subtract from 0, I will get 200, so the bottom of the screen. That would also be nice. So we have Game of Life running on a torus. That would actually probably be even cooler. Yeah, maybe we'll do that, because then we actually can also scale it up pretty easily to different resolutions, I think. And it would be nice to see gliders moving out of the screen and coming in on the other side. That's not bad. Yeah, so I think I have to take a look at the rules. The rules were simple. There were 3 rules. No, 4 rules. Any life cell with fewer than 2 live neighbors dies as if by underpopulation. Any life cell with 2 or 3 live neighbors lives onto the next generation. Any life cell with more than 3 live neighbors dies. And with exactly 3 live neighbors, it becomes a live cell. Aha. Okay, so basically we need to read first of all, we need to check if our current cell is... No, we need to count the 8 neighboring cells, no matter if we are alive or dead. And then, at least that's the simplest rule that we can do. Then we check if our cell is alive or dead. If it's alive, we know the rules. If it's less than 2 that we counted in the first thing, then we set it to dead in our second thing. Oh, yeah. Actually, you know what? I think we don't need the VGA page here in the update game, because we need to look at... We're gonna define this the following way. We just call update game. We don't need that, because we always look at VGA page 1, since we're swapping the values anyway. VGA page 1 is the one that we are updating, and VGA page 2 is the one we are looking at for reference, or the other way around. Maybe the other way around, because we are we wrote our initial state onto page 1. Okay. Can you still follow me? Let's see. So basically what we need to do is we need to call get pixel 8 times. 8 times, and we need to update the... Oh, this will be ugly. Can we write this in a nice fashion? Or is this just pretty ugly? Does TurboAssembler actually have like a convenience for calling functions where they do the pushing? I should probably check with my TurboAssembler manual that we did have somewhere. Here's the manual. The arc directive. Can we do stack maintenance? Let's see from the start if there's something. Calling a subroutine that wipes out needed registers. Interfacing TurboAssembler with TurboC. Where's my mouse cursor? Ah, my mouse was falling off the mouse pad. No, that's not what I want. Extended call statement with arguments and optional language parameters. That's what I'm talking about. But where do they have this? Let's take a look at the index. There's probably something in there. Call instruction. Labels and something, subroutines and something. Hmm, 93 and 162. 93. No. 162 is much further up. 1.6 to how subroutines work. Yeah. Parameter passing here. No, I don't think they show any convenience functions, because that would save us a lot of typing, shouldn't it? Okay, then we are doing it the hard way, I guess. So how did we do this? We wrote yx page. Okay, yx page. Yeah, we need to have a running variable here. What do we call it? Shall we call it dx and dy? No, dx is already reserved. I and j, like in C? I'm not sure. Because that would probably not be a good idea. Any good names? Any good ideas for the names? Let's call it pixel x, pixel y, and what did I say? VGA pixel 1 is the thing that we're looking at. Exactly, this is the one, the previous state, and that should actually be y, x, and that. Then we call get pixel, and we get in ax, or in, what was it? I think in a something, al, we get the byte value. Okay. And we probably shouldn't use 0f, because then we can just simply add everything up. We should use, we can change the palette later. So we are going to, let's just call this color. No, we're just gonna use 1. I'm just gonna use 1. I'm just gonna use 1. We won't change that. We will change the palette later. Are you still alive, people? I don't see anything in the chat. Have you all gone away? I could understand if you did so, but please bear with me. 1, 1, and 1. Yes, that's fine. I'm gonna reload. I'm not sure if my browser crashed. No, you all have gone away, it seems. It at least says 13 people are still watching for some reason or other. Yeah, so this will get the first pixel. We have to initialize that. We will put that into memory. Pixel x is a word, and we start off at 0. Pixel y is also a word. We start off at 0. What else do we need? Oops. We probably need some constant. Maximum x is... You're here, yes. Can someone see this text? Yes, yes, you're all here. I think maybe the lag got worse. Not sure about that. maximum x is 320, maximum y is 200. So that's our dimensions of the screen. And yeah, here we should do something like morph pixel y comma 0, morph pixel. That's actually crap, isn't it? Actually, we should split it. The problem is, if you don't introduce a lot of functions or procedures, it's hard to think in terms of this. I'm very used to doing it the C-style way. So let's say we have something called line and we have something called column. We start both at 0, or let's do it from the bottom to the top because that's easier. Max line and column, max y, and this is max x, and we will do this here and call it loop lines. And at the end of the loop we will do a decrease column, and every time this reaches 0, jump not 0, we will go to loop lines, and outside of this we will decrease the what is it called, line, and if that isn't 0 we will go to, that's garbage, loop lines. Yeah, we need something like loop columns. So loop columns, and this is jump loop lines. So this is 2 loops, basically 2 for loops, counting down from 200. That's probably stupid because we need to start at 199 and 319. Yeah, because we start at 0. So these are 2 for loops. The outer loop iterates the line variable, and the inner loop iterates over the column variable. So we go over the screen from the bottom to the top, and we will check in there for the 8 neighboring pixels. And that's now the tricky part, because this is a lot of code, not complicated code, but stupid, a lot of code. So basically what we need to do here is morph pixel y comma line, and morph pixel x comma column. This is the current pixel, and we can already get that and store that in another variable that we are calling current pixel or something, and this will be a byte, and we will initialize this with 0, because there we can determine if the current pixel was alive or dead, right? So we initialize this, we call getPixel, and then we morph current pixel comma al, and we will comment this so that we know it. Read current pixel alive or dead. Good. Next thing is we need to read in the 8 neighbors, right? So that's a lot of decrementing and incrementing and things like that. I'm just gonna, I will start off with very inefficient stuff. Accumulate all 8 neighbors. And this can be done much more efficiently, I think, but I'm not going to do it just yet. That will be something for a third part or something. I just want to get it to run. So we load pixel y and pixel x with line and column. Then we need to first decrease pixel y and decrease pixel x. And right now I'm not checking for wraparound, so we probably get a little bit of garbage, but I'm gonna fix that later. Horst asked, will you do wraparound of the map? Yes, I will, but not in the first try, because right now we don't need it because we just have this spinning flippy thing. But eventually I will. Right now we will get a little bit of garbage in there at the borders, maybe, but it shouldn't be too bad, because right now if you run out of the screen at this point, even with the mode X, you will come in over here. Okay, so it will not be that bad, but you won't read the correct value anyway. But this is now, let's write what this is. This is -1 relatively to the original pixel, and we will call this, and then we will add neighbors. Oh, let's also clear that variable, mof neighbors, comma 0. Add neighbors, comma, is it actually possible with add, or do I have to use AX or something? We will see, but this is what I'm thinking of, at least. So we need neighbors, db0. This is the first neighbor. Now I'm gonna decrement this and not decrement pixel x. This can be optimized, of course, because we still know that pixel x is actually, we just have to increase it. And I'm just gonna do this, I think. Actually what would be correct would be increase pixel x. This will give us this neighbor. Gives us a little bit less code, which is probably also good for readability. And this will give us this neighbor. And now for the next trick. We are not doing any tricks, it seems. Better, okay. Now we are trying to, oh, I'm a bit stupid. -1, 0, 1. No, it's fine. Now we are trying to, oh yes, let's do it really clever. We are now increasing pixel y and staying with pixel x. This gives us the neighbor 1, 0, so we are going basically in a zigzag pattern. This will, we can't ever debug this. We are lost. And now I'm gonna do the 0, 0 we don't need, but because that's the same thing, we don't need that. Minus 0, 1 will be dec pixel x twice, because if I remember correctly, we can only do decrement by 1. So this will be minus 1, 0. Next up, will be minus 0, 1. So we need to simply increase pixel y. Then we're doing 0, 1 by increasing pixel x, and the last one, oh my goodness, this is a lot, will be the lower right corner, and we're again increasing pixel x. After this magnificent beast of code, which probably can be refactored to be much more clever and much faster, we have the current pixel in the variable current pixel, and we have in neighbors the number of neighbors that are alive. So let's see if this compiles or if we have to do something. Oh, we have to do a lot. Okay. Okay. Column and line, column data word 0, line data word 0. Undefined symbol loop columns. No, I think I have that. This should give us slightly less. VGA pixel 1. What was that? Yeah, because I'm stupid. That's not VGA pixel 1. Let's replace this. How do I replace? Nobody knows. Replace control QF is find, and replace is replace. QA. Find VGA pixel 1, VGA page 1. Yes. What was the options? What was the options? I can tell it to replace everything. Search globally. G. That's better. Okay, we still have a bunch of legal memory references as usual, because that's what we're good at. 96. Okay, this is memory to memory. That's probably not allowed. Mof line comma max y. So line and max y are memory allocations, and that's probably not allowed. So we need to change that. So let's try this. Mof ax comma max y. Mof line comma x. Is this now gone? Yes, it's gone. Same goes for this. Mof ax comma max x, and like this. Then we have an illegal instruction in 101 because we forgot the column. That's better. Relative jump out of range. Oh dear, that's gonna be fun. No idea why that is the case, but we will see. 104. Okay, here we have the same thing. Morph AX, line, morph pixel Y, AX. And here the same, morph AX, column, morph pixel X, AX. Uh, 117 and 118 have the same problem. Yes, of course. Morph X, line, morph pixel X, pixel Y, X. Morph X, column. You get the gist. And that's why you use a compiler. And now we have something weird. 181. Okay, this is too long a jump. Why? Because there's too much stuff in between. How many bytes can we jump with the jump instruction? Why is this too large? Come on, where's my mouse? Where is my mouse? Does it say somewhere? Not in here. So relative jump out of range. Relative jump out of range. On short jumps. Okay, Horst. The question is, we can of course, it's probably better to put this into a procedure, right? I would say. Because this will get more complicated anyway. So, time for another procedure. This procedure will be called neighbors, accumulate neighbors. And procedure accumulate neighbors. You know the drill. Morph BP, no, push SP, push BP. Morph BP, SP, BP, SP. Pop BP red. What do you say? Short jump is 65536, but it's absolute to the segment. Far jump is full segment offset jump. Yeah, I'm not going to do this. I'm going to use a call. We are doing that anyway. So I'm gonna take all this stuff. Yeah, I'm gonna put everything in here because we can into this function or procedure because it doesn't return anything. It's completely riddled with side effects. Terrible, terrible. Okay, relative jump. Okay, yeah. Short jump is CS offset. Okay, yeah. I think we will manage with this. So basically, I'm just calling accumulate neighbors. That should do the trick, and that actually works. And dare I try to run this? Yeah, of course. This is either very, very slow, which I believe might be true, or I forgot to probably forgot to increment or decrement a running variable or something. No, I did. I actually did. Let's debug this before it gets any more complicated. Open a comp file. So we have to find the update game proc thing. And the update game proc happens here after the vertical retrace. So here's the vertical retrace, 34F. Oh, 3DA. And I think this could be it. Yes, this is actually the last part of the vertical retrace, and this should be the update function. So we're pushing, we're moving, and what are we doing in here? Update game. Ah yes, we are updating the variables. C7 should be something like yeah, 199 exactly. So that's good. And let's see, this will get the neighbors, and this already hangs. Okay, so accumulate neighbors already hangs, so we did something wrong in there. Question is what? Maybe problem with the out instruction. I think you messed the byte order because little endians. No, I think not, because that actually worked before. I think we already established that the vsync works, but once I tried to step over the accumulate neighbors, we had a problem. So we should have a look at this. We are probably messing up the stack here for some reason. So a stack frame is push BP and mov BP SP. That we do have. Push BP and mov BP SP. Then we are trying to read the current pixel, and we are setting up another function call for get pixel. We never tried out the get pixel routine, right? Maybe that is broken. The AX register, I think, doesn't matter. I think that's fine, because we are also... Yeah, no, that should be fine. I can mess with the AX registers, I say. But I think the get pixel routine probably doesn't work. We're gonna try this out. We're gonna debug this and see where it hangs. Also, I think we need a third part. We did quite a bit today, and in the middle of coding the game code, the actual game code, but I think I can do maybe 10 more minutes, but then I need to call it quits. So let's once more open the live.com, and that should happen. So this should be the entrance into the game update function. Yes. Then we go in here. Is this the... No, there's another. Okay, this is the call 0303. That should be the... Yeah, this is the get pixel routine. There's the map mask register selection. Then the computation of the offsets. Can you upload the file right after streaming? Would like to go on with it. Yeah, I will try to. I will put it in the... I think I'll just update the gist, because I can just make another commit to that. So the URL of the last will be valid, because I will put the recording public as soon as possible, but probably not today. But you can use the link from the last live stream, and we'll put the code in. You're welcome to play with it. Shift right. So pop DS, pop BP, red, which looks fine. We ended up at the right place, which is always a good thing. Some memory updates. Then we are decreasing the running variables, and let's try this. We might just be stuck in an infinite loop because I did some garbage. That is very well possible. So this is doing all the neighbor stuff. That does work. Then we're adding to the count variable. Then we pop BP, we read. And then we are somewhere completely wrong, I think. Yeah. We ended up, or no, this is correct, is it? I don't know. There is a call, but is it the right one? Yeah, I think I have to meditate about over this a little bit. This looked to me not quite right. So there's definitely an infinite loop for some reason. Either we are messing up the stack in one of these things here. You all say we should save the AX register because why? Oh yeah, you're right. We are overwriting. Are we? No, we're not. It doesn't matter because we're just using this as a temporary in the update game. Lorenzo, what are you thinking? Tell us. Do you also think that the AX register should be saved, or is there a different problem? Well, anyhow, I think I'll upload the gist now, and then we have some music, and we're gonna have a third stream either in a week or two. Let's see, depending on what we can do, and we can just edit and upload a different version. Let's go to downloads, C drive, let's code, no, TASM, and then live assembly. I think that it's an endianness problem. I don't think so, but let's see. Maybe you're right. Maybe you're right, maybe I'm wrong. Here we go, slightly unformatted. Here's the second try, getting longer. We will need to condense this down to something smaller. There's already way too much code, and we can write this probably in a much more efficient fashion. I want to be below 512 bytes, and I think we already cracking that. But still, I would say okay, but we put some pixels on the screen, so how do you explain that? It did work. Okay, because we were not doing that in the set pixel, right? We're doing that in the, yeah. Not sure. Yeah, I will meditate on that and print out the stuff and read it in a quiet moment. Anyway, I will have to say thank you very much for watching, very much indeed. I hope to see you soon for the third part. What did we achieve today? We got setPixel and getPixel more or less running, I think. We seemingly got the page flip to work, but people are having doubts if that's absolutely correct. But you can have a look at, oops, you can have a look at this stuff here, if that's right or wrong. But it's very easy to rewrite that we don't need to use that or swap around the registers. But I don't think this is what's crashing us. I think there's a problem with the game update and the stack maybe. But I think we are almost there. We need to fix a few bugs. We need to code the actual rule in the end. We accumulated all the neighbors in theory if we fix the bugs. And then we just need a couple of decisions if we need to set a pixel to 0 or 1. And that's about it. So I think when we fix the endless loop here and implement the rules, we should have a running game of life in the third part. And for that, I thank you very much. If you're not yet subscribed, please hit the subscribe button. That's always useful. Make sure to check out the other videos. Also tell your friends and family and everyone you know about this channel, because everybody needs to watch it, obviously. People just don't write assembly anymore, so we need to change that, definitely. And yeah, I think this was a very nice stream today again. I had loads of fun. I learned a couple of things again. I forgot so much about assembly. And let's see if I can manage to do it next week or the week after or something. There's a lot of other stuff that needs to be done, of course, outside of streaming and coding. So, any wishes for the outro music? I think I downloaded only 3 new mods today, and I haven't got the newest release from Freddy. He wasn't here today, I think. But I would say this one was new. Yeah, I'm gonna play some music and let you watch the outro. So see you next time.